Welcome back to Real Terms for AI. Today I wanted to just talk about something just a little bit different.
What's that?
On-device AI or Edge AI.
What's that?
Running AI applications without calling back to a server for every prompt. Thus far in the series, we've primarily talked about applications where most of the code, including the business logic, runs on a server. That includes any calls to a foundation model or any use of AI.
Most of the examples have been about websites and backend data pipelines, but a lot of the techniques and architectures should work anywhere, right?
Yeah, for the most part, the techniques and ideas we've discussed can be used on a backend web service, an AI agent running behind a web endpoint, an app on a phone, or even an agentic flow running on an embedded device like a robot.
So let's be clear what we mean by on-device here. What definition are you using?
The definition I'm using is some sort of AI agent or application that uses a model, and that model is running on the same device as the AI agent or application. In a lot of our examples, I've assumed that the model is running in the cloud or you're making an API call to it. When I talk about on-device AI, I'm specifically talking about applications and agents where they call a model that is on the same device where the application is running.
So instead of calling a model that's on a remote server somewhere, you're using a model that's local to that specific device.
That's what I said.
We've talked about this a bit in the past, but refresh my memory. What's the advantage here of using that local model?
Well, an obvious one is latency. The model is on the device, so you don't have to wait for a round trip to a remote server.
And since everything stays on the device, privacy and security, I could imagine, would be advantageous too.
Yeah, those are some other reasons that for some applications, using a local model might make sense. And another reason some folks prefer using on-device models is cost. If you're calling a remote foundation model, you're likely paying per token, or you have some other way you're paying for that usage. And if you're calling your own endpoint that hosts a custom model, you're still paying for ingress and egress and the costs of hosting that model in general. With local models, you can often reduce those costs.
But then why doesn't everyone use local on-device models all the time?
So there's two big reasons, and they're related. The first one is model size and context size. The models that can be run on devices right now have smaller context and fewer parameters.
And fewer parameters and smaller context put some limits on the kinds of prompts that we can use and the kinds of tasks that the model will be successful with?
Yes, and the limits will going to vary model to model, but perhaps it can only handle, say, smaller images, or it has a limited context window that makes it less useful for certain types of summarization tasks or RAG tasks where you need to put a lot of data in the context window to answer a user's question.
Sounds like what we say a lot, that it always depends on the use case.
It always depends on the use case. And I want to be clear, often the models that you can use on a device are great and they will work just fine for your use case, but you'll need to test them out to make sure that they work for your specific use case and that you'll get the quality that you want.
Now, you said that there are two reasons that folks may not want to use an on-device model. So that was one. What's number two?
So another one might be package or download size and needed computation capacity. Many demos and on-device model applications that I've seen include a small model as part of the application bundle, whether that's the page that downloads in the browser or the app that downloads to a mobile device. In certain environments, like if you have bad connectivity because you're camping or in my living room, the time it takes to download, that may be an issue for the user, and they would prefer to call the model remotely as needed. And also, on computation power, often only the latest versions of devices or software can support applications with built-in models. So not all your users will actually be able to benefit from your AI experience or even potentially run your app.
I thought that application developers could use AI models that were already on the device, though.
So for newer devices, and in some cases, yeah. The AI tools built into the system support some use cases and may even give access to an AI model within certain parameters. And I just want to be super clear with the audience here that capabilities are changing rapidly and vary a lot between devices. So the developers should check what is supported by the environments where their application is going to run.
You said capabilities vary between devices. That sounds like even you can use local models in some use cases, but you probably can't use them all the time.
Yeah, so that's another challenge with using local models. Since supported use cases vary and devices vary in their support, you may need a hybrid approach if you choose to use a local model for your AI features.
New term alert, hybrid. You mean using a local model when you can and a remote model via API when you can't, right?
That's exactly it. And there are tools to help you do exactly that, so you don't have to write as much code for this as yourself. Firebase AI Logic is one example. These tools make it easier to switch between the local and remote models as needed, and you can even use both in a single application, depending on the exact prompts you need to send and the exact part of your application you're coding up. I've put a link in the description box below for folks that want to learn more and potentially try this out in the applications that they're building.
Sounds like an on-device model is a good option for some use cases because of the speed and the privacy and cost benefits, but it probably is one of those things where we should check the use case and whether this actually fits.
Yeah, that's exactly it. And honestly, this is something I'm really excited about and I'm watching closely to see how this technology develops because it is changing rapidly as more capabilities are brought to devices and people try new things and teach the rest of us. It's really new tech.
We're super lucky that new tech is basically all that we do, right?
It is so awesome.
All right, with that, this is Jason and Aja for Real Terms wishing you
Happy
prompting.